Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum, and I'm here today in the Military Historical Institute, the VHU, in Prague, in the Czech Republic, taking a look at some really interesting experimental and prototype Czech firearms. And today we have two examples of possibly one of the coolest looking submachine guns ever developed, the ZB47. So this was developed by primarily by a guy named Václav Holek. He is a legendary Czech arms designer. He was the designer behind the ZB26 light machine gun. He was assisted in this project by his brother František Holek. For some reason, Czech gun designers almost always come in pairs of brothers. But the design actually began in the late 1930s, before World War II, but it didn't fully become realized until after the war ended. So in the years after World War II, the Czech military was really interested in adopting a submachine gun. They had tried to do so. In fact, they did technically adopt a gun. It was the VZ38 submachine gun in 9x17 in 380, right before the war, but it never went into production. So they come out of World War II with no submachine guns at all. There's a whole bunch of wild development in the late 1940s. In particular, in the summer, in July of 1947, there's a major trial with like 7 different submachine gun designs from a bunch of different companies. And one of those entrants was the ZB47, designed by Holek and manufactured by Brno. So Brno was, at the time, a government-owned small arms factory, and they put quite a lot of work into developing this extremely unusual submachine gun. So the basics here, what makes this really unique is that the magazine actually runs all the way along the bottom of the gun, almost in parallel with the barrel. And then it has a rotating mechanism up in here that takes cartridges that are pointing this direction and feeds them 90 degrees up into the barrel. You can think of this like the Czech version of the P90, just more than half a century earlier, and with about 50% more magazine capacity, because this guy holds 72 rounds. So let's dig into this. We're going to tear this completely apart and show you how it works, because it is a fascinating design. All right, we're going to take a close look at all of this weirdness, but we're going to start with the markings. So on the right side, we have Samopal ZB47. Samopal just means submachine gun in Czech. Model is ZB47. B is Z is Zbrojko, which is weapons manufacturer. B is for Brno, where these were manufactured. Now, this particular one has a Czech lion crest on the top of the receiver, and it's dated 1947. And it is serial number 1013. These serial numbers started at 1000, by the way. Our paratrooper example does not have the crest. It's dated 1948, and it is serial number 1039. And then they are both marked Zbrojka Brno, so weapons manufacturer Brno. This particular one has a Czech Army proof mark dated 1947. The paratrooper example with the collapsing stock does not. So this is a gun that was made by the factory after the end of the military trials, when they were attempting to get these adopted elsewhere, which, spoiler, they never did. The other kind of fun marking here, you may have seen this circular ZB Brno logo on some of the commercial guns that Brno made. Well, they integrated it into this pivot point, the hinge point between the upper and lower receivers of the gun. So there's the Z and the circular design there. The sights here are close to the same, but have subtle differences between the two examples of the gun. So we have this flat-topped barleycorn post for a front sight. And then the infantry model has these two small side wings and a 2-position V notch. So it's 100 meters here and 300 there. The paratrooper model here is virtually identical on the front sight, but the exact design of its rear sight is just slightly different. Again, 100 meter and 300 meter V notches that can be flipped like so. There is one other marking on here, and that's this little brass plaque, which in Czech essentially says only for conical ammunition, or only for conical. And what that means is the specific cartridge that the gun is made for. Now, because the magazine is so long on this, I mean, it's a serious stendo there. This is 72 rounds, but standard 9mm Parabellum actually has a slight amount of taper to the case. That's why, for example, with the MP5, you see it originally released with straight magazines, and then they changed to a slightly curved magazine. Like a lot of the really good 9mm magazines, submachine gun mags, are curved. The Sterling magazine is another good example. Well, when you get a straight magazine this long, that curvature actually starts to stack up and make a difference. And this was causing them feed problems in the magazine. So what Brno did is they redesigned their own version of 9mm Parabellum with a perfectly cylindrical case. And they attempted to convince the Czech Army to use that cylindrical case because this could stack up in a very long magazine without any problems. In fact, the P90 does exactly the same thing. The 5.7x28 cartridge has a perfectly cylindrical case so that you can stack 50 of them in a row in a box magazine without needing a curve to it. Interestingly, that's also why P90 ammunition, 5.7 ammo, is generally lubricated, because the slight taper of the 9mm cartridge is very helpful in getting successful extraction. As soon as it moves back in the chamber just a little bit, because it's tapered, it's broken contact with the chamber. A straight-walled case, a truly straight-walled case, remains in contact with the chamber all the way through the extraction process. Anyway, the point I'm getting at here is that some of these ZB47s were made for standard ammo. Some of them were made for this specialty straight-wall ammo. Brno was never able to convince the Czech Army to adopt the straight-walled cartridge, and for very good reason. They tried to come up with some benefits, like, you know, if you have the straight-walled cartridge, you can use enemy conical ammo, but the enemy can't use your guns. None of it actually took. Anyway, that's what that plaque is for. Now, this particular gun is made for standard 9mm ball, and these, by the way, I have several of them here that we'll be using, are dummy rounds so that I can show you how this actually feeds. Let's take a quick look at the controls. We have a selector lever, safety and selector lever here on the left side. It is 0 in safe, 72 is full auto, and there is no semi-auto functionality on here. Rate of fire was apparently about 1,200 rounds per minute, so extremely fast. Right up there with like the Papashaw 41s. On this side, we have a charging handle, and we have a magazine release lever. Now, to actually insert the magazine, what you have to do is put the back end of the mag in, lay it down in the gun, and then snap it forward. There we go, like that. And we have this tab at the front end of the magazine that sort of locks into position when the magazine is properly seated. This really is not an ambidextrous gun. The way it's supposed to be held is like this. In the right hand, of course. You sort of have the selector lever under your thumb. Kind of. It's a stiff lever. It's not quite right there, but it is accessible. And then on this side, you just have your trigger. If you do hold this left-handed, you end up with your selector lever under your finger. It's a little bit uncomfortable. All right, for disassembly, we're going to use this rotating wheel here. When it's pointing at Z, the gun is assembled and ready to fire. And what I do to field strip it is rotate this all the way down to O, and then the gun pops open. Now, what's actually happening here is that this lever is camming the upper it's camming the upper receiver forward from the lower. So you can see when the gun's assembled, it's locked in place here. And as I rotate the lever, this pulls forward. When it's all the way forward, it opens up like a shotgun or like many other designs. So this will, in fact, open up a full 90 degrees, which will allow us to pull out the recoil spring and the bolt. But to make it a little bit easier for you to see, I'm going to do a full disassembly. So I'm going to rotate this back to the U position, where this little cutout lines up with that notch, and then I can pull this component completely out, and then I can just separate the upper and lower receivers completely. Once we have the upper off, we're going to just lift the recoil spring out. There we go. So that's your recoil spring. You got a little bit of a cloth pad back here as a buffer. I can then pull the bolt out, just pull this back, and it lifts out. And it's got this weird arm on it, which is an integral part of our feed mechanism, which is super cool, which we'll get to in just a moment. And then I can also pull the barrel out, because there's actually nothing holding the barrel in place. So there's the barrel and the barrel extension. So when the gun is actually assembled, the bolt and the barrel extension lock together like this, with this arm off on the left side. And you have this double feed ramp. But that's only half the feed system. The other half of the feed system is here in the lower assembly, and it's this rotating set of lugs. So when the bolt is cycling, this arm is going to hit this left side tooth, and it's going to push it forward, just like so. It's going to cycle back. The next time you fire, it pushes forward like that. And each time, what's happening here is this center tooth is pushing a cartridge up and out of the magazine. So if I install a magazine there, you can see it happening like that. And in fact, we can load some dummy ammo. Put that in there. So there's the front round in the magazine. That's the first half of the feed system. And what that is going to do is push the cartridge up into this feed ramp, where it comes into roughly this position, at which point the bolt is now there, and the bolt chambers it the rest of the way home. So the manufacturing techniques here are really pretty interesting. Like, there's a lot of technical work that went into making this submachine gun outside of just the design of the mechanism. So the upper receiver is all stamped, but it's several different stampings that are welded together. So we can see a couple of seams. You can see some weld seams. Get some light on it in there. The lower is even more interesting to me. So this top surface is a machined part that then has stamped elements welded to it. So you can see, again, weld seams there. You can see weld seams on the inside there, here, especially right up in there, because they needed very flat, precise surfaces and carefully located pinholes for the fire control group, which, by the way, we've taken out here. You have really, like, they put a lot of machining time into just the trigger and sear as well. But you don't want to have to machine this entire thing from billet, especially because it's all hollow. It makes a lot more sense to just stamp this. And so what they did is combine both features, some stamping and also some milling. Let's see, at the front here, we can take this out. You've got a big central spring that compresses this against the side. So there's the front end of the feed mechanism. So that's the receiver field stripped, well, except for taking out the mag release, which, well, and safety, which we don't need to do. But a lot of interesting manufacturing elements going into that. I also want to mention this guy. This is the paratrooper version. So the idea was to have a collapsing stock to reduce the overall length of the gun. However, it's the stock back here that is the storage space for the whole magazine. So if you have a collapsing stock, you can't very well have a 72 round magazine in it. So what they did is simply give it a shorter magazine. The paratrooper version had a 30 round magazine, pathetic, paltry 30 rounds. And then this lower assembly simply ended early, and they put a sliding stock on it. So just one position there, that ball bearing locks it in the extended position, push that in, and collapse it back down. Worth pointing out that when the stock is fully extended, it will take the full-size magazine. You just can't collapse the stock with that in there, and also this makes a fairly lousy cheek weld. A couple other functional elements to point out. When the gun is on safe, you cannot operate the bolt handle and the trigger is locked. It does fire from an open bolt, so if I put this back into the fire position, I can lock the bolt open. I can then engage the safety. It still locks the trigger, but now it's locking the bolt in the open position. This tab on the magazine, by the way, prevents you from disassembling the gun if the magazine is still in place, which would be a bad idea. There we go. Now without the mag, I can open it up. This tab here, which is part of the trigger itself, is what locks the bolt in the open position. So when I have the gun in the fire mode, which it is right now, this can drop all the way down. And this means you can manually cock the gun. It also means this effectively works as a safety mechanism where it takes enough force to push this down that if you just drop the gun when it has a loaded magazine in it, the bolt won't be able to overcome this force. It won't be able to pop open, grab a cartridge, and fire it unintentionally. Now, when I switch this into, that locks this block up. And at that point, if the bolt is forward, it can't push this down and it can't come backward. So a fairly clever safety mechanism built into the gun, especially considering it only actually has two moving parts aside from the safety lever itself. Another cool thing to point out is that there is actually a round counter in the magazine. So when this magazine is installed, the round counter is visible right here. If a person is holding the gun, obviously I don't have the upper on it right now, but if you're holding the gun in a shooting position, you can just kind of roll it over and you have current magazine capacity right there, easy to see. And the way they did that was by putting this marker plate on exactly the right calibrated coil of the spring. So this is set basically at the bottom of the magazine. So there's the whole magazine spring. When this is compressed inside the magazine, this at the bottom is only going to move just a little bit as the top of the spring compresses. So it allows them to actually show you capacity from 0 all the way up to 70 rounds on a short plate inside, like right at the base of the magazine. This was really interesting. I didn't expect this when I opened it up. I was thinking of examples like the Nambu light machine guns that have a round counter on the mag, but it's just on, well, on the Nambus, it's actually located on the follower, and so it only counts down from the last 3 rounds. This, very cool, actually gives you the full capacity at all times. Just to show you, here is our fully cylindrical round in a barrel that is cut for regular conical ammo, and you can see it doesn't fully chamber. It's still about a 1/4 inch out of the chamber. And that's because this round is actually larger at the shoulder, at the front, than the chamber is. All right, so I have the recoil spring out here, and if we look at this arm, what's going to happen is when the arm goes forward, it is being held in the upward position. It's going to ride on the top, because this is upside down. It's riding on that side of this rail in the receiver, which is going to force it to rotate the feed mechanism through, chambers all the way forward, and then when it comes back, it is actually on the underside of this rail, essentially to reset. So similar to guns like the Madsen or the Maxim that have cams on the inside of the receiver, that's what this rail is. The ejector, by the way, is right there, and it's built into the barrel extension. All right, I want to give you a feeding demo here. So I've reassembled the gun without the recoil spring in it, and if I just dry cycle this, the bolt goes back, hits the sear, I pull the trigger, bolt's going to come forward. That front arm is going to hit the feed system, so you can see it rotate forward right there. Then it'll chamber the round. Now let's put in a magazine with some dummy ammo. Now, pull the bolt back, and let's see if we can do this slowly. It's going to, there we go. There comes the cartridge up the feed ramp, it pops up, and you can see as soon as it clears the bottom of the feed ramp, the nose of the bullet is in the chamber, so that's still being controlled, and then the bolt can chamber it, just like that. One more time here. There we go. There it is being lifted up into the chamber and done. All right, so I mentioned that in July of 47, this was in a major trial. Now, the result of the trial was, first off, the troops really actually kind of liked this. These were sent out to 8 different units of assorted military, infantry, and some other specialties. And of those 8, 5 sent back really positive reports on these. However, the military administration decided the gun was really too fragile to be a viable option for mass production and adoption. In addition, it had some serious shortcomings in accuracy. The magazines were fragile, it was too easy to damage the receiver. Like, there were kind of a litany of potential problems here. But it's really interesting to me that the troop trials reports actually came back fairly positive, because this certainly looks like a very awkward gun to handle. But in practice, yeah, it's a little weird, but not that bad. At any rate, it didn't make it past the trials. In total, from the beginning of development, the first model of this was ready in 1946. Like I said, development began in the late 1930s, but didn't really get going until after the war. A grand total of 62 examples of these guns were made, including the early models, the paratrooper, the infantry, all told, 62 of them. So they're extremely rare guns today. The 2 winners, the 2 best candidates from that major submachine gun trial, one of them went on to be adopted, well, developed a little more, and then adopted as what we know today as the CZ, or the SA 23, 24, 25, 26. At the time, it was the VZ48. The other one that came out of that trial looking very good was the 476. That actually went on to be the inspiration for the Israeli Uzi. So we'll cover that in a separate video, but the ZB47 certainly has the distinction of being one of the most unique looking of all submachine guns, like, ever. So hopefully you guys enjoyed the video. I'd like to give a big thanks to the VHU for giving me access to both of these prototypes to take a look at, to take apart, and to show to you guys. The museum attached to the VHU here in Prague is fantastic. They have some pretty extensive galleries of small arms dating back hundreds of years, in particular with a whole bunch of cool exhibits on World War I, World War II, and conflicts since. So if you have some time, you find yourself in Prague, definitely put aside at least half a day to come check out the Czech Army Museum. Thanks for watching.